Now, continuing in the same trend, now that we have done this first exercise, this and this, now we are going to solve question A. For the question A, question 2, line A. Okay, they say use ratio test for or to check the convergence of the series. Okay, let us use ratio test to converge to try to test this convergence. Okay, use, this is what they ask. Okay, this is what they said actually. Okay, it is to use, use question 2A, use ratio test. They are asking for use ratio test to test or to check the convergence of the series. And what is the series there? Okay, what is the series? The series is, this is the series actually. Okay, sum from n to infinite of 2 to the power n plus 1 and 3 to the power n plus 1. Okay, 2 raised to n plus 1, 3 raised to n plus 1. Okay, now what do we have to do this here? Okay, raised to n plus 1. So see, they asked us to apply this ratio test. Okay, so by ratio test, we know that in ratio test we have this expression, limit where n goes to infinite is equal to what is of un plus 1. Okay, the one term, must be the ratio between the one term and its antecedent, the number that come before him. Okay, this limit, if this limit is equal to L. Okay, this limit says that if L is less than 1, so this un converge. Okay, un converge, sorry, that messages. Okay, this guy will converge. Okay, if L is less than 1, so this series converge, but if L is greater than 1, the series diverge. But if L is equal to 1, test fails. Okay, this fails. Okay, it means that we have to jump to another test. Okay, but here they ask us to solve according to this according to this test. Let us just solve. So first we will have limit of un plus 1. Okay, un plus 1 upon un, n goes to infinite. We know what is un here. Un, okay, what is un here? Un is this expression. Okay, so un plus 1, it is just you pick up this one, and where you find n, you will substitute by n plus 1, like this, 2n plus 1 upon 3n plus 1 plus 1. Okay, you will divide by un, that is 2n plus 1 and 3n plus 1. Nice. Okay, so this limit where n goes to infinite will be equal to 2n times 2 plus 1 upon 3n times 2 plus 1 time the inverse. We know that we cannot divide fraction. We just keep the first and multiply by the inverse of the second. So it will be 3 to the power n plus 1 upon 2 to the power n plus 1. Then what we have to do here, see, here usually you take common, this guy, and this guy, and this guy. Just take common, take them common. Okay, it's factor, common factor, like 2 to the power n. Okay, just do 2 to the power n, 2 plus 1 divided by 2 to the power n. Okay, 1 divided by 2 to the power n. And here also do the same, 3 to the power n. Here it's 3 plus 1, 3 to the power n. Multiply. Here do the same for this, 3 to the power n. This will be 1 plus 1 upon 3 to the power n. And here 2 to the power n. And here 1 plus 1, 2 to the power n. Okay, then what you get here, 3 to the power n, 3 to the power n will be cancelled out. Okay, let me use my red pen, this one, and this one. So this limit will be only equal to 2 plus 1 upon 2 to the power n upon 3 plus 1 upon 3 to the power n, okay, time the same, 1 plus 1 upon 3 to the power n, and here 1 plus 1 upon 2 to the power n. Now I know that this one, okay, this will be 0, this will be 0, this will be 0, this will be 0. How? It's very simple. So I can write this one in this way. This will be 2 plus 1 upon 2 to the power n. And here 3 plus 1 upon 3 to the power n. This is the same. And here, what I will get, 1 plus 1 upon 2 to the power n. And here 1 plus 1 upon 3 to the power n. Okay? See, whenever I have a infinite, a goes to infinite, yes, a to the power infinite, okay? If this a, okay, a, yeah, what will be this guy? A to the power infinite will be 0 when, this will be 0 when a is in between 1 and 0, like this, okay? If a is in between 1 and 0, so a to the power infinite is 0. So here, see, 1 by 2 is in between 1 and 0. 1 by 3 between 1 and 0. So this will be 0 because n is infinite. Okay? N is infinite. Substitute for n infinite here. Just substitute n infinite. You will get 2 plus 1 by 2 infinite. Okay? Time 1 plus, okay, can you see? 1 plus, okay, 1 by 3 infinite. Okay, 1 by 3 infinite to the power infinite. And here also the same thing. Okay, we got 3 plus 1 by 3 infinite time 1 plus, okay, 1 plus 1 by 2 infinite. Okay, yeah, from here what you will get, see, this one will be 0, this will be 0, this will be 0, and this will be 0. You got only 2 times 1, 3 times 1. 2 by 3 will be the limit. Okay, let me see. So this limit, I will write down here, limit of 2n plus 1 upon 3n plus 1 will be 2 by 3. So 2 by 3 is less than 1. So if 2 by 3 is less than 1, by ratio test, just see here. When the limit is less than 1, it is convergent. So this will converge. By ratio test, this limit, this series converge. Okay, which series? This one. Okay, you remember, no? Equal to 1, 2 to the power n plus 1, 3 to the power n plus 1. Okay, thank you. Next time we'll see you again.